Trudy, you know what that is? What is it? It's an ice. Now, what state of matter do you think it's in? Solid. Feel it. Is it rigid? Is it cold? Some properties of ice. That's good. So I got an ice. Right now it's a solid. If I put it in this beaker, did it take the shape of the container?
No.
No, it still retained its shape. So here, I have a beaker. Full of water, has an ice cube. Here, I have a beaker. It has water, and now an ice cube. We're going to put a flame to it. We're going to put a flame to it. Where's the fire extinguisher? Point to it. Where's the fire extinguisher? Point to it. Everybody, point to it. Where's the fire extinguisher?
Over there.
Point to it. You're not? Nope. Everybody needs to point to the fire extinguisher.
Where's that?
Point to
Right
it.
there. It's right there.
Nice. It's good to know where safety equipment is located. It's not that I'm worried about my hair catching on fire. It's my eyebrows. And if that happens, you stay there. I'll pat them out. So here we go. Can you see the ice cube in there?
Yeah.
Flame. Here, we're looking at the molecular level. Macro, micro, molecular level. Where we can see the molecules in the water. And then if you look at the ice cube, you can see the molecules are there, but they're lined up. So let's put the spurs to this one and see what happens. You look and you start seeing the molecules break away and the ice cube is shrinking. And the molecules are moving around in the water. Now the solid's gone. So there's none lined up in rows and put together. Here we've got liquid. And it's free to move about. Out here we got gas and they're moving everywhere. Down here it says temperature is 20 degrees Celsius. Let's see what we're at here. 60 degrees Celsius. We'll see if it catches up. How's the ice cube looking here? Is it getting bigger or smaller? Smaller. Okay, well it's gone here. That's because it was a really tiny ice cube. It had a really big ice cube. So we're at 52 degrees Celsius. Here we're at 76 degrees Celsius. And look, we start seeing these molecules are moving around because it's a liquid. It's got some room to move. Where's the ice cube? Gone. There's no more solid in there. Let's see what the temperature is. Temperature is 86. Oh, we're at 81. I timed this about right. Second period. And we're at about 100, real close to each other. You'll start noticing some things. Okay, we're getting close. Looky here. I think the flame here beat it. It's at 95. What's happening here? What do you see? What do you observe? Some boiling. Wait, if you look right here, look. See some bubbles. Now pay attention to some of these molecules. You'll watch. Oh, there it went. You'll watch. Some of them will come up here and then just take off. Because it changes from a liquid to a gas. The same thing's happening here. 103.8 degrees Celsius. Here, 100 degrees Celsius. There's a lot of other things that made that go up a little bit higher. Okay? So, as this boils, these molecules find their freedom. And they go out here and they become a gas. The same thing is happening right here. The ice cube, that was a solid, became a liquid, and now we're boiling the water and it's become a gas. Do you guys see wisps of steam?
No.
God bless you. You guys ever seen one of these?
Yeah.
See that dot?
Yeah.
It's telling me the temperature of that poster is 23.4 degrees. That's all this is a thermometer. From 33.4 degrees Celsius. This is going to go, as this goes, you'll notice the water level's coming down. Here, it's kind of hard to tell because there's a lot of bubbles going on, but we could eventually boil this long enough to where there's no more liquid. But I broke a beaker during the first period when I did that. Can you see it?
Yeah.
Did you see it?
Yeah.
That's gas.
Yeah.
States of matter.